don't stop.
Let me explain something.
Good afternoon, everybody. Welcome to class today. Thank you for joining me, whether you're watching live or you're watching the recording. I appreciate you watching. Sorry about the little late start in getting you all the message today. Got stuck in a little meeting this afternoon that I thought was going to end just a little bit earlier, but we got there, and the recording will be available, so if you weren't able to attend live as a result, it's completely fine. Last week we did Module 1, got you accustomed to some environment there. I haven't graded the assignments yet, but I went through and looked at them, and by and large, I think everybody, it seems like everybody did a great job. So now we're moving into Module 2, and the way that I've kind of organized this course is that each module focuses on a different little puzzle piece, right? Like one of the things that I say a lot is that, when it comes to programming, teaching programming is difficult, right? Because when you get out into the real world and you actually get to writing programs, nobody's ever going to give you the program that you need to write, and they're never going to show you a direct example of the program that you're going to need to write. But you're going to have to write a lot of code, and you're going to have to, make things work when maybe it didn't work before. And so as a result, a big trick behind programming is being able to get all the little bits and pieces. I might call them puzzle pieces. Right? And so what I try to do in this sort of course is I help you try to understand the pieces of the puzzle. And then in a bit of a controlled environment, you all try to take these pieces of the puzzle and make them look like the picture on the box. So every single thing that you have to do in every module, you actually don't need anything but the pieces that are given to you in that module to be able to complete successfully. So if you find yourself having to go outside to other means, having to look for other things to being able to complete a lab, besides the things that we cover in a particular module. And when I say module in that sort of way, I'm talking about the combination of these live classes and what's online in the different modules in the Blackboard class. If you find yourself having to go out to do a lot of other stuff or look up a lot of other stuff that's not necessarily what exactly we covered in the module, there might be an easier or different way to do it. So just to keep that in mind. But we're starting Module 2 this week, and Module 2 is about putting data into buckets. If you've had my previous classes, you know that this is an analogy that I really like when it comes to the concept of variables. I refer to a variable, and we'll talk about it in a little bit. I refer to a variable as a container or a bucket, and then I have a little programming demonstration that we'll do toward the end of our live class today that also takes the idea of containers or buckets or jars and kind of puts it into perspective, right? You'll see what I mean when we get there. But we're talking about variables, and by extension of talking about variables, we're also talking about operators. Operators being, in this case, with what we're doing right now, arithmetic operators. So when it comes to what we're doing here, relatively simple, relatively easy. Right, we're going to try to break things down into as small a pieces as possible, and we're just going to work our way through it. So, the first question that we would really need to ask is just what exactly is a variable? So let's talk for a few minutes about what a variable is. A variable is a container, right? So we can think about a variable in that sort of way. Just a container. Think shoebox, think jar, think Tupperware, whatever helps you think about a container. Just some sort of empty vessel. And this is an empty vessel that you can put stuff into and take stuff out of. And so if I'm looking at a variable in that sort of way, right, I can look at my container. And this container is just that. It's just a container, right? It's just a bucket. And I can put data into here. And in turn, I can take data out of here. And so that's kind of useful on its own, the fact that I have a container here that I can put data into and take data out of. But what's really valuable when it comes to the idea of a variable is that a variable is a symbolic representation. So not only do we have a container here that we can put data into and take data out of, but we put a label on this container. And this label names the container, right? So we have some name here. And so what that does is that name becomes symbolically linked to the values that are inside of our container. So whenever I refer to the value that's inside of my container later on in my program, I don't have to refer to it by that specific value. I can just refer to it by its name, whatever that might mean. Or whatever that might be, rather. It means its name. Another good thing about this is that I can change the values that are in this container, right? I can update it, I can increment, I can decrement, I can completely change it while I'm working with it, which isn't a huge deal now, but it will be a huge deal in the future. So that's two big things, right? Like I can name it and then just refer to the name in other places in the program. That means that I have to just change the data that's in the program less. I can update the data by taking data out of it and putting new data into it. And then a third thing comes in the area of composition, right? Where I can take whole big long equations and put them into a container. And so my container can hold a whole big long equation, so I don't have to write out a whole big long equation every time I need to work that equation. I can just put that variable in there and have it work for me, which minimizes the ability to make errors, right? Because if I have to take one big long equation and write it out over and over and over again, then that's going to increase the amount of possibilities that I have to make a mistake, right? And it also limits the areas where a mistake can happen, right? Because if I only have that in there one time, and I go to my program and I run it and my program's not giving me the output that I would expect for it to, then I know that equation is isolated in that variable, so I know to go back to that variable and change that equation to make a change to fix my program. So a variable, getting ahead of myself, because I'm going to say a variable is super valuable to us as we are writing programs. Now, when we're thinking about a variable, and this is a little more than I do in regular intro level classes, right? Because this is a Java, more advanced, more computer sciencey class that we do. So I don't normally talk about variables in this sort of way. But a variable has multiple properties that are associated with that variable. And for the purposes of this course, we focus on 3 of them. We'll bring in 4 a little later on in the course. Right, but a variable has 6 properties that are associated with that variable. Name, type, and value. And these are the 3 that we're going to be focusing on. Our name, type, and value. Name being that label that's on my container, right? The symbolic name that relates the data inside of my container to the container itself. Type being a data type, right? Remember, one of the things that we talked about last week is that Java is a strictly typed language, meaning that when I create a variable, I need to make a promise to my program, to my compiler, about the type of data that's going to be in that container, about the type of data that's going to be in that variable. And it has to have some sort of value, right? And this value could be numeric, it could be alphanumeric, it could be an equation, right? The value can be a whole lot of stuff, right? And that's just the data that can be in this and that's just the whatever data can be in this variable. Scope, we'll talk about scope a little bit later on. A little bit when we talk about scope, we will talk about scoping more in terms of when we're starting to write new methods ourselves. We'll talk more about scope and variables being scoped to a method. We'll also talk, when we talk about loops, we'll talk about variables being scoped to a particular loop or a particular bit of code there as we're writing code. So scope will become important as we progress a little bit later on in the semester. For our purposes in this class, since we're just kind of getting started and we're just kind of doing the basics, we're not going to worry about lifetime. We're not going to worry about location and memory, although we can find that information. We're not going to worry about that information as we are kind of going through. So for right now, as we're getting started with variables, we're just going to worry about the first three, which are name, type, and value. So the first thing that we're going to do is we're going to want to be able to name our variable. Right? We're going to want to be able to name our variable. And so as we're naming a variable, a variable name must begin with a letter, an underscore, or a dollar sign. We're starting a variable name with one of these things. And these are the only things that we can start a variable with. We can't start a variable with a number. We can put a number inside of our variable name or at the end of our variable name, but we cannot start a variable name with a number. Basically, the reason why we can't start a variable name with a number is that, one of the things that we discuss is that our interpreter, especially as we're getting started, right, we'll talk more later on about certain structures that can change our flow of execution. But in general, our interpreter runs our program top to bottom, left to right. And so as our interpreter and our compiler are reading the code, if it sees a number there, it thinks, oh, I need to be able to do math with this. I need to be able to do math here. Because it sees a number and it immediately thinks math. That's what the interpreter does, right? Remember one of the things that we talked about last week was that our computer is dumb. And so since our computer is dumb, we have to be real specific in what we tell it. And in general, we tell our computer that, hey, if you see numbers, you got to do math. So if we put a number at the beginning of our variable name, it's going to think, oh, time to do math. And then it's going to see an A, an S, a 7, a T, something that's not an arithmetic operator. And that's just going to be, and it's going to confuse it, right? It's going to be confusing to our interpreter. And so that's basically all there is to it. Right? So we want to make sure that we're starting with a letter, an underscore, or a dollar sign. Now, any other point after the first letter, you can put numbers in there if you want, right? It's A-OK. We don't put spaces or special characters. The only special characters that we can use inside of our variable is the underscore. The dollar sign can only be used at the beginning. Right? So since these rules are real specific in terms of using special characters, my suggestion is just not to use special characters at all, just so you don't forget. And besides, naming conventions in Java are typically camel-cased anyway, right? So we shouldn't have to worry about an underscore as we're kind of going through. Variable names can be any length, although we want to keep it short, right? If one of the benefits of using a variable is that we can take something that's super long and condense it down to be the name of the variable, then having a super long variable name does us no favors. It is case sensitive, so if we use an uppercase A in our variable name as we create our variable, we have to use an uppercase A in the same place when we reference that variable, right? That goes back to what we talked about last week as well. And no Java keywords. These are the Java keywords that I'm referring to. And so keywords are words in Java that are already used for another purpose. And so if they're already used for another purpose, then we don't have to worry about using them, or we can't use them for our purposes, right? Because they're already reserved. They're already held back. And we have the big list of those here: abstract, assert, Boolean, break, byte, case, catch, char, class, const, continue, default, do, double, else, enum, extends, final, finally, float, for, go to, if, implements, import, instance of, int, interface, long, native, new, package, private, protected, public, return, short, static, strict, FP, super, switch, synchronized, this, throw, throws, transient, try, void, volatile, and while. Right? And I think I have these listed in your module as well. I should if I don't, right? I'm fairly confident that they're in there. So we can't use any of these words as a variable name. Now, just to kind of test yourself, right? I created this just little thing to where you can kind of see, will this work? Right, so based on the rules that we just learned, will each of these variable names work? And why or why not? So if you're watching the recording, go ahead and pause it here. Maybe take a little sheet of scratch paper, write down like if you think each of these will work or not as a variable keyword. If you're here with me live and you're looking at these variable names, maybe just take a minute. If you have a piece of scratch paper handy, write them down. If you don't, just kind of think about it in your head. Think about like, well, is this okay? Is that okay? Right, so just look at these 6 examples here and determine whether or not you think they will work or whether or not you think they won't work. So we'll just hold for just a second, just to for anybody watching live, so they can kind of think it through. And see if you get it. So 3, 2, 1, and here are our answers. So the first one, yes, it'll work. It's just a word, right? Even though it begins with an uppercase letter, it's just going to work. Second one, no, not going to work, right? Why won't it work? Because it's got parentheses in it. Parentheses will make it not work. Third one has an underscore in it. Underscore is okay, right? Although ideally, if we were, going by Java standards, which are just style rules, ideally we'd rather see this as just camel cased to where the new word started uppercase with no space or no underscore in between there. But grade underscore test is still fine. For test, no. Why? Starts with a number. Can't start with a number or it thinks time for math. Default, no. It was on that list, a screen earlier. It's one of those reserved keywords. $sign at the front is A-OK. So that's just fine. The $sign comes from some old school days of kind of programming. There are certain programming languages where you have to have a $sign to indicate that a certain thing is a variable. So in this case, right, this is just fine. And so that kind of gets us through naming, right? So of the three things that we said we wanted to do, we wanted to have a name, we wanted to have a type, and we wanted to have a value. So that basically gets us through naming, the idea of naming. So let's talk about types. Variable types. So since Java is a strong typed language, meaning that variables must be explicit or declared in type by the programmer, we have to include types as we declare variables. And for our purposes, right, we have a bunch of different variable types here, but really the only ones that we'll ever need to use are the ones that we have here in bold. There might be an instance where we need a long instead of an int. But in most instances, an int is going to work. Double is a floating point number or a decimal number, right? We use double instead of float for precision sake, right? Because a double will go further past the decimal. Boolean being a true or false. We'll talk more about Boolean a little bit later on in the course. And then string, right? Which for our purposes, we really don't declare a string variable in the same way that we declare other variables in Java. I prefer to use string objects to declare a string variable. And so here in just a moment, we will look at how we do that. And actually, let's just go ahead and do that now, right? Like, no better time like the present. So I'm here in a replit, right? And what I'd like to do is I'd like to just kind of declare variables and give them values. Right, so let us zoom in here so you all can see this just a little bit better. And so the first thing I'm going to do is I'm just going to go in here and delete this line. Now, as you're working, you can keep that line in there and use it later, right, when you're ready to print something out of your console. I'm perfectly fine with that. I like to get as much practice as we can as we're kind of going through. Right, and one of the things that I say a lot is to let your past successes influence your future successes. So since we know kind of how to do that, system.out.println statement now, especially after last module, this should be a piece of cake. So let's start out by creating an integer variable, right? And so that's just int for the data type, right? So we're making a promise to our compiler that what we're about to do is going to be an integer, and we can just give it some name here. So I can just, for our purposes here, let's call this just some num, right? And so this is the name that we're putting on our container. It's just some num, just because we're going to put just some random number in it, right? And so let's put like 124 in here, semicolon at the end. Now you see we get the yellow squiggle there underneath some num, and that's because we've declared this variable, we've assigned it a value, but we're not using it anywhere, right? Like, so if I hover over it, that's what it'll say. And let me zoom out so you all can actually read that. The value of local variable some num is not used. Right? That'll go away when we actually print that out. Now there are some instances, and we'll talk about some use case examples for this a little bit later on in the course, right, where you'll need to declare a variable, but you're not quite ready to use it yet. So in these instances, I can actually use a data type and use a name to make an empty container. So for example, if I were to create an integer, another num, and just throw a semicolon at the end there, this is fine. Right? This has just created an empty container in memory in my Java program, and it's waiting for data to go into it. So one of the important things to remember if you are declaring but not assigning your variable right away is that after you've declared your variable, which is what's on the left hand of the equal sign here, you don't have to declare it again, right? You just assign. So at some other point in my program, my compiler already knows that another num exists because it's created this container in memory. So instead of having to promise the data type that's going to be in there again, I can just type the name and set it equal to some value. So we still see that yellow line there, even though it has a value now, it's still not being used. So we can print them out, right? And we can do a couple different things at this point if we want to print them out. For example, let's say we wanted to take these two numbers and add them together. Ideally, I would do what's called composition here, where I would take two variables and use another variable to combine them. Right. One of the things that I could do is I could say, okay, system.out.println, and just add some num plus another num. And that's going to work just fine. Right. That's going to print out 475 to my console, which is what it should do. But ideally, this gets a little sloppy, and I might want to make changes, and I might want to use those results somewhere else. So what I might do in this instance would be to create another variable, call it int sum total, and add the variable names in there, right? Sum num plus another num. Right, so now we're doing this equation, which is just going and grabbing these values from their containers, putting it in the equation, and saving it in this variable. So I can sum total. And that's going to give me the exact same result, which is the result that I want, 475. Now, I said that strings, or the way that I want us to handle strings, is just a little bit different, right? You can, for all intents and purposes, create a string primitive and set that equal to a string value, and that'll work, right? That's just fine. However, for our purposes, I like to create a string object, which is just a little bit different. It's just a little bit different. And so as we're creating a string variable here, the way I would prefer that you all do it is to do it this way. String and the variable name, which in this case is hello, equals new string, and in quotes inside of those parentheses for our string function here, this is where you put the result, or what you want your string to be. And this is just a little more efficient when it comes to memory, right? It creates a new instance of a string object in memory that it applies these letters to. And so now if I wanted to print that out, I can system.out.print line hello. And it's going to print out our string value, our string object value here, which is hello world, to our console along with our 475. Which we see here. And so these are the basics, right? These are the basics when it comes to variable creation and assignment in Java. Now this is also the module where we come up with operators. So I'm just going to go through these really quickly so we can get to a demo today. And so for the time being, at least, when we're talking about operators, we're just talking about the basic mathematical operations. Right? We're just talking about arithmetic operators. We'll introduce some more advanced operators in the next module that'll help us do some different stuff. But for now, we're just going to use plus, minus, multiply, and divide. Java also follows the order of operations rules, as you learned it in school, PEMDAS. Right, so if you want to make sure that part of an operation happens before another part of the operation, the easiest way to ensure that is just to make sure that you have parentheses around the part that you want to go first. We'll talk more about rounding errors as we progress, but one of the interesting things here is that with floating point numbers, most floating point numbers in calculations are only approximate. And so it rounds repeating numbers and irrational numbers. right? And this is where we get to the idea that, it was one of those, it was a meme on the internet several years back, but it's also true when it comes to Java programming, that 0.99999 and continuing equals 1. Because basically with the way Java handles rounding, it's going to hit the point where it can hold all of the numbers that it can hold in the memory for that data type. And it's going to round it. And so with 0.9999999 in particular, it rounds it up. And when it rounds the last number, it has to round the next to last number, and it has to round the next to last number to that, and so on and so forth until it only gets to 1. And so you get 1 as a result. There are ways that we can get more precise results that we might talk about later in the semester, but as this is just a beginner class, right, we just want to be aware of rounding errors at this point in time. For the vast majority of our calculations, rounding errors are going to be a non-issue, right? Only in matters of like tolerance and where things have to be like really, really, really specific is it going to become a huge issue. And again, there are ways that we can combat that, which we're not going to get into now, but we may later. And this is another explanation for why that happens. The idea of a terminating fraction. A terminating fraction in decimal, which is a repeating fraction in binary. And again, that's why the whole 0.99999 goes. And like I can show you that, but not a huge deal. So we'll just kind of leave it alone. We're getting pretty late in the class, and I want us to see the demo. So again, we'll look at the solutions for that later on. String operators. And so this is the concatenation operator. Right, so this allows me to take a string and add it to another piece of data. If you're familiar with Python, you might also be familiar with the repetition operator. Repetition operator doesn't really exist in Java. Right, basically the only string operator that we have in this purpose is our concatenation operator. But it just allows us to put strings and variables together. Right? So if we were to look at that example that we just did, I can use my concatenation operator, which is my plus sign, which will allow me to put these two things together. Now in this instance, it gives me hello world and the number together on the same line. Now, one thing to notice here, right, is that there is no space between the number and hello world. What I want in my output needs to be in my input. So if I want a space between these two objects in my output, I need to put it in the input. So I need to also concatenate a space here as a string to put that in there. So when I run that now, I see now we have a space between 475 and hello world. So this shows us that not only can we take variables and concatenate them with other variables, but we could take strings and concatenate them with existing variables. So again, I could do something like system.out.println the number is colon space, and concatenate that with sum total, for example. So then we get the number is 475 in our output here. So let's take some time before we get ready to wrap up here, and let us do a little program. So I'm going to take what I've done here so far. I'm going to wrap it in a block comment. So it will be there for you all to reference, but it will not influence the code running that I want to have in here as our example. And so if we were in class together, right, I would do this as a coding challenge or a programming challenge. And I would ask you all to write me a program that will help me calculate the volume of a cylinder. Volume of a cylinder. And I say to use 3.14159 as the value of pi. Right? There are ways that we can get more precise values of pi. We talk about them in a later module. Right? Remember, we're snowballing. And so the volume of a cylinder, right? And this is what I was talking about earlier when I said, the example, the demo that we're going to do later has to do with containers. Right? Because we can think about a cylinder as a jar or a can or a barrel or any sort of cylindrical object, and the volume of it is how much it can contain. So we have basically a cylindrical container here, and we want to know how much it can contain. Just like our variable is a container. And so we're going to use 3.14159 as the value of pi. And the volume of a right cylinder, which is what we're doing, right? We'll keep it simple, is probably not one that you have just memorized. Right? It's probably one that you'd need to look up, and that's okay. But the volume of a right cylinder is pi radius squared height. So the height being the height of our cylinder, the radius being the radius of one of the circles. We're going to square that radius. Right, because what we have here is basically the area of our circle, pi times radius squared, a pi r squared. And the height here being the height of our cylinder. So we can think about, this area being available for this height. We don't have to worry about the top circle because it's kind of irrelevant, right? Like if you think about like a cup, if you had a perfectly cylindrical cup, you would fill it up. Doesn't have a top, right? So these are the things that we need to calculate. This part being So we have the area of a circle, we have the height, we have pi. So I want to create variables, and this might be a bit overkill for our purposes here, but since we're practicing variables, I want to create variables for pi, right? Since we're not using another programmatic value of pi, we're using a value that we're determining for pi, which is 3.14159. So I want to create a variable for that. I want to create a variable for the radius. I want to create a variable for the value that holds the radius squared. And I want to create a variable that holds the value of the height. And then to get really granular, I might want to create a variable that holds the area of the circle and create a variable that holds the volume of the cylinder. So, this is kind of that planning that we were talking about, right? When we were talking last week. This is me kind of doing a little bit of planning here. It's me thinking through all of the things, right? And it is a bit overkill to do every single one of these variables, but we're practicing variables and we're practicing doing math, so it's probably a smart idea for us to do them, right? So let's head back over here now to our Replit. So what I'd like to do here is I'm just going to write a little single line column here, or single line comment rather. So you all, as you're looking at this code later, know what I'm talking about. Right, so the first thing that I want to do is I want to take and create my value of pi. Now my value of pi is a decimal number, and in these instances we use float for all of our decimal numbers. Float is floating point number. So we're creating a new floating point number here. We could also, if we wanted to, we could write it as an object, right? Just like we can do as a string, but a float is a primitive. So just for demonstration purposes here, I can both write float pi equals 3.14159, and I can write float, uppercase F float, pi equals new float 3.14159. Both of those are valid, right? It's throwing me a fit here because I use pi here and pi here. But instead, right, what I want to do, and I want this to be a double, don't I? I want it to be a double instead of a float. I don't want it to be a float. I want it to be a double. This double is more precise, as we said. Getting late in the day. Same thing applies, though. I could do both. It's fine. So that's my value of pi. We put it in a double. We haven't used the variable yet. I can create an integer for my radius. I could do that, right? That's completely valid. If I were to do my math with whole numbers and multiply a whole number times a floating point number in Java, it's going to do some automatic typecasting and give you a floating point number as a result. However, what I want to do is I want to give my program the best opportunity to have the most precise data. So in this case, instead of an integer, I want to use a double here as well. And let's just put a number like 3 in here for the time being. It's going to automatically assume 3.0 in this instance, and that's fine. Right? And so we use double here in this instance instead of integer on the off chance that, a measurement can be a floating point number. Right? Our radii for our circles might not always be a perfect nice integer. Sometimes they might be floating point numbers. It might be 3.7 millimeters wide or whatever. So now let's double radius SQ for radius squared. And so in this instance, I can just take radius and multiply it by radius to get radius squared. So again, this is a little bit of overkill, right? We're practicing variables. And in doing so, we do a little bit extra. Right? I wouldn't necessarily do all of these steps if I was actually writing this program, but that's, neither here nor there. Then I can find the area of a circle, so I can take area circle. We'll make that a double as well, double area circle. And the area of my circle is pi times radius squared, so I can take my pi value and multiply that by radius squared. We'll create a variable for our height, which will also be a double for the same reason we made our radius a double, just on the off chance that it is a floating point number. In fact, let's make it a floating point number. And we'll say it's 12.2. And so now in this instance, all we have to do, right, is we can create a variable for float, or double rather, cylinder vol, and set that equal to our area of a circle times height. And so now when we print out, all we have to print out is our cylinder volume. System.out.println cylinder vol. Semicolon on the end. So we run that. It does all the math for me. It gives me 344.946582. Right, so that's a bit of a complicated number. Right, so one of the things that I might want to do is make these numbers simpler, just to test my program to ensure that it's working. So in this instance, what I might want to do is I might want to take that radius and maybe make it 1. Right, so in that case, 1 times 1 is 1. The area of my circle would be basically 3.14159. Right, because it's going to be 3.14159 times 1. And then I can take my height and basically say, okay, well, let's just make that 2. That way it's a different number so I can see if everything's working. And so what I should expect is like double pi. Right, so this will round, 9 will round up and it'll do its thing. Let's just see what we end up with. 6.28318, right, which is what we can expect. Right, that's our pi value doubled. Because we can take and say 3.14159 times 2, and we get 6.28318. Which is exactly what we got here. So by taking that equation and simplifying it down, we're able to see it work. And so then we can be more confident in the outcome if we were to use larger numbers. That might have a lot of precision, a lot of decimal places. We can be more confident in the response here. So the only thing that we'd have left to do maybe would be to give some context to this output, which we can do that via concatenation. The volume of this cylinder is cylinder volume, units, and volume is cubed units, right? So we can say units cubed. And so now we've given some context to the results of this equation. We can also print out lines that are like specifically pointing to the radius is blah, the height is blah. We can have a title for our program, and so on and so forth, to really take this to the next steps. Let's see, I need a space there, so I need to add it to my output. And we get that. And so we've only got about 3 minutes left in our hour here, so I want to go ahead and stop here. That basically covers everything that I wanted to cover anyway. We'll pause here for questions in case anybody who's here with me has them. So if you're here with me live and you have questions, you can drop them in the chat. If you are watching the recording later on and you have questions, please send me an email or a Teams message to figure out, and I will answer them as soon as I am able. So we'll just hold a minute or two here for questions. Is the only reason for declaring a string as an object to save on computer time, basically. Yeah. It handles the memory a little bit better, declaring your string as an object than it does declaring it as a string primitive. Either works, though. It's not a big thing. No. No, not really. It is a better practice, but it doesn't really have a huge impact, right? Either way. So there's not a big difference between the string object and the string primitive. Like, there are some reasons why, but they're kind of beyond the scope of this class. So especially with where we're at now, either's fine. Okay. Cool, cool, cool. Well, we'll hang out in the chat just a couple more minutes just to, with the music playing, just to answer anybody's questions who might have anything lingering. But that's all that we have for today. Want to thank you all for watching, and we'll see you next time.